This is pre-calculus video on section 2.4, solving rational equations. That means solving equations with fractions. And so here's what you need to know. If you've got two polynomials on the top and bottom, the only way that any fraction can be equal to 0 is if the top is equal to 0. So whatever polynomial is on the top equals 0. The bottom can never be equal to 0. So if there is any solution that gives a 0 on the bottom, then it is irrelevant. Doesn't matter what it does on the top. It causes the solution to not to be true because you can never divide by 0. So I'm going to take the numerator and set the numerator equal to 0. This is a quadratic equation. So let's see, are there factors of -6 whose sum is +1? 3 and -2. This is a factorable quadratic. First times first is 2x times x. Outer times outer has to be -2. So 2 times -1 gives me that -2. Inner times inner has to be +3. So 1 times +3 gives me that +3. I'm going to set those factors both equal to 0. And then solve those two equations. Okay, so these are possible solutions. Okay, I'm picking up in the middle of this problem. I made a mistake on my first recording. I'm going to try and splice together my correction so you don't have to watch the mistake that I made the first time I recorded this video. When I left off in solving the top of this equation, so I have my 2x squared plus x minus 3 equals 0. I solved that just a moment ago, and I found that x was equal to -3/2 and +1. All right, so now what I'm going to do is I'm going to look for extraneous solutions. And to find extraneous solutions for fractional equations, I'm going to look to see what values of x make the denominator 0. All right, you know that if you can never divide by 0. So if the denominator is 0, then it's the fraction doesn't even exist. All right, so any value that you plug in for x that makes the denominator 0 could not possibly be a solution to this equation. So I'm going to look for those values. What values of x make the denominator 0? All right, so let's see if this is factorable. I'm looking for factors of 6 whose sum is 5. And the magic numbers are 2 and 3. So first times first has got to be 2x times x. Outer times outer has to be +2, so 2 times 1. Inner times inner has to be +3, so 1 times 3. I'm going to set both of those factors not equal to 0. And then I'm going to solve both of those inequalities. I'm going to subtract 3 and divide by 2. All right, so I've got two values that would make the denominator 0. All right, when I solved the top of this equation, I had two values that would make the numerator 0. Bear with me. All right, so the two values that make the numerator 0 are -3/2 and +1. But the denominator, or the numbers that would make the denominator 0, are -3/2 and -1. So since x cannot be equal to -3/2, right, that means that this could not possibly be a solution. So -3/2 is an extraneous solution, and the only true solution is x equals 1. All right, that's it. Okay. All right, so I'm going to take the top and set it equal to 0. The numerator is equal to 0. Let's see if this is factorable. Are there factors of -8 whose sum is -3? 1 and 8, 2 and 4. All right, none of them are equal to -3. I think I have to do this using the quadratic formula. X equals -b plus or minus the square root of b squared minus 4a. C, that's a -4. All over 2a. It's 9 plus 32 all over 4. The square root of 41 all over 4. Okay. All right, so that's an irrational number. 41 is prime. The square root of 41 can't be simplified into a rational number. The denominator says that if x were equal to 4, then 4 minus 4 is 0, and you can't divide by 0. So that means that since my solution to the top part was some irrational number, it's not equal to 4, that means that it does not contradict a solution. And so therefore, again, that is a true solution to my equation. All right, that's it for this video.